This is Joel Dinan and Owen Smith for Stats Video Project. Our question is, a true and false test consists of 5 questions. That means there's a 50% chance of each question being correct when guessing. Let's assume a student doesn't study and randomly selects the answer to each question. Why does this situation represent a binomial distribution? It represents a binomial distribution because there's only 2 outcomes. There's a correct and incorrect answer to every question. Whether that is true or false doesn't matter. What matters is the fact that if it is correct or incorrect. You can even add more questions to this. It will affect the probability, but will not change the fact this is a binomial distribution. Keyword being bi, like biweekly, every 2. So on to the second part of this question. What is the probability of a student getting 5 questions correct? And for this, we need an equation. So the equation we use for this can be broken up into 3 pieces, the combination and the 2 pieces of probability. So to solve this equation, we need 3 pieces. We need n, x, and p. C is just a placeholder for combination. And through this, P and N will not change because there is no different qualifier saying it will change. So N and P are respectively 5 because N is the number of trials, so 5 questions, and P is 0.5 or 50% because over those 5 trials, each of them has a 50% chance to be correct. And X is your number of successes or failures depending on what you're searching for. In this case, we are searching for 5 correct answers. So X is 5. So actually getting into how to solve this, it would be 5 combination. 5 times 0.5 probability to the power of 5 times 1 minus 0.5 to the power of 5 minus 5. Now this breaks down to 1 times 0.03125 times 1, which ends up equaling 0.03125, or roughly just a little bit over 3%. So that is the answer to this. Probability is 0.3125. Moving on to the next question is more complex than what is the probability that a student will receive 3 or more questions correctly. So that includes number 2 and the probability for 4, not just 3. So let's tackle 3 first because that's what the question first outlines. So the only thing that's going to change here is x because we're now searching for 3. So the number of successes is going to change to 3. So it's 5 combination 3 times 0.5 probability to the exponent 3 times 1 minus the probability of 0.5 to the power of 5 minus 3. This breaks down to 10, 0.125, and 0.25, ultimately ending in 0.3125. Interesting that 1 and 3 are the same number, but different variations on where the decimal is, ultimately equaling a near 31%. So we have 3.125% from earlier, or the decimal 0.3215. Now we're going to find 4. And like I said, the only thing that is changing is x, so x is now 4 in this equation. So 5 combination 4 times 0.5 probability exponent 4 times 0.1 minus 0.5 to 5 to minus the exponent 4 breaks down to 5 times 0.0625 times 0.5, which ultimately equals 0.1215650, which we add up with the others for probability because these are not mutually exclusive. They actually end up being 50% possibility to get 3 or higher in the test. And that may sound wrong because people are going to think probability is 1, 2, 3, 4, and 5, but you're forgetting the chance of getting every question wrong, which ends up ultimately adding all of these equal 1. So that's the answer to the question, and I'm signing off.